Okay, so number one says find the inverse of the following one-to-one function. So this function is one-to-one. So you are already told it's one-to-one. And it kind of makes sense it is one-to-one. So this kind of reminds you why this is a one-to-one function. So let's see why it's one-to-one. So remember, to determine if a set of ordered pairs is one-to-one, do that mapping. Put y first, x next. So when y is 4, x is 7. When y is 1, x is negative 8. When y is negative 2, x is 6. When y is 5, x is 0. When y is negative 8, x is 2. So you see, for each y coordinate, there's only one x coordinate. So you're told this is a one-to-one function. So it's already one-to-one. Now what you want to do is you want to find the inverse. All right, you want to find the inverse. All right, now remember this step here. So remember when we found the inverse algebraically, you remember this little part here where it says interchange the variables? X becomes y becomes x. That's the idea you're gonna do here. So watch. The 0.74 becomes the 0.47. X becomes y. I'm sorry, y becomes x becomes y. That's all you do. To find the inverse of a one-to-one function, if it's a set of ordered pairs, you just interchange the coordinates. So negative 8, 1 becomes 1, negative 8. 6, negative 2 becomes negative 2, 6. 0, 5 becomes 5, 0. 2, negative 8 becomes negative 8, 2. And that's it. There's your answer. So the inverse of this relation is this relation. And it goes back to the idea of finding the inverse algebraically. You interchange the variables. You interchange the coordinates. So let's look at the next one. Now, notice so you see right here, all I said was find the inverse, and so you just have to do this. Here, though, you're given the set of ordered pairs, all right? But I didn't use the words find the inverse. So I didn't use those words. I use this instead. So if you see this, remember this negative 1 means inverse. So I want you to find f inverse. So this is your function f, and you're told it, and you know it's one-to-one. How do you know it's one-to-one? Watch. Do that mapping. Y, x. When y is 9, x is 0. When y is negative 1, x is 2. When y is 6, x is 3. When y is 2, x is 4. When y is 1, x is 9. So notice for each y coordinate, there's only one x coordinate. So this is one-to-one. How do I find, now remember this means f inverse, so remember that, f inverse. So to find f inverse of a set of ordered pairs, all you do is interchange the coordinates. That's all you do. So that means this. Here's the answer. 0, 9 becomes 9, 0. 2, negative 1 becomes negative 1, 2. 3, 6 becomes 6, 3. 4, 2 becomes 2, 4. 9, 1 becomes 1, 9. That's all you do. Okay? All right. Now, the rest of this is very similar. It's very easy. It's very similar to another worksheet you had. So let's look at this one right here. So remember what this means. This means what is y when x is 3? That's what that means. When x is 3, what's the y value? But you see it says, if you look at this, you have two functions. You have f and you have f inverse. So make sure you use the right one. So you go to your function f, so that's this one. Okay, that's this one. So when x is 3, what's the y value? Well, here's the one where x is 3, right? When x is 3, what's its y value? The answer is 6. So you're going to use this one. I'm looking at f here, my function f. So you're going to use this set of ordered pairs. When x is 4, what's the y value? We got to find the one that says 4. When x is 4, what's your y value? The y value is 2. Now be careful here. Don't make sure you go to the inverse. You got to use this one. So f inverse of 1. So what's f inverse of 1? Well, f inverse of 1, when x is 1, that's this. So you got to use f inverse now. When x is 1, what's my y value? Well, my y value is 9. You see, you got to make sure you're using the right function. Here, f inverse of 2, make sure you're using the right one. It says f inverse, so you got to use this one. When x is 2, see this is 2, when x is 2, what is y? Well, when x is 2, my y value is 4. All right, and that's all you do there. Now let's look at 3. So in number 3, you're told, well, first of all, it didn't say it here, but assume h of x is a one-to-one function. Because if it's one-to-one, then it has an inverse. So see, now we can talk about the inverse. All right, so listen carefully to what this is saying. So this is saying this. So you're told it has an inverse, right? So you on a previous worksheet, and I don't know which one it was, but on a previous worksheet, you were given this and you were asked to write this as an ordered pair. So note, h of 4 equal -3 as an ordered pair is, all right, so remember, when x is 4, my y value is -3. So is 4 -3, just like this, okay? So if this point is on h of x, is on h of x, then -3, 4 is on h inverse of x. All right, so that's the idea we did here. So if your function has the point 7,4, then the inverse has the point 4,7. If your function has the point -8,1, the inverse has the function, so the inverse has the point 1, -8. So if 4, -3 is on h of x, then -3, 4 is on the inverse. And so here's what they're asking. What is h inverse of -3? So when x is -3, just like we did here, made a comparison. Look, see this right here? F inverse of f inverse of 1. You went to the inverse. When x is 1, my y value is 9. That's that same idea you're using here. H inverse of -3. When x is -3, my y value is 4. And that's all it is. So it's just you're using here this same idea that you used here when finding the inverse, and then ask about these values. Number 4. Number 4, you're given your function, it's a linear function, you're given this function, and you want to find h of 3. Well, that's easy, because remember, to find h of 3, wherever you see the variable x, you substitute 3, right? So h of 3 will be 6 times 3 plus 5, 18 plus 5, which is, what, 23? That's what you get, okay? Now look at this. What is the value of h inverse of 23? Well, use those same ideas that you've been looking at. So listen carefully. So let's assume, well, first of all, you know this is a line that rises, so it's a one-to-one function. So h is a one-to-one function. So it's going to have an inverse. So what we just found here is this. H of 3 equals 23, right? Which means, so this means 3 comma 23 is on the graph of h of x. Well, since h of x has an inverse, this also means that if 323 is on the graph of h of x, this also means that 23, 3 is on the inverse, h inverse of x. So now look at this. What's h inverse of x? Well, remember what this means. When x is 23, see right here, when x is 23, what's your y value? Well, y value is 3. So h inverse of 23 is just 3. So make sure you kind of look at this in the terms that we're talking about here. It does make sense looking at it that way. Part C. Find the value of x if h of x is 47. Okay, the way you want to do this one is this way. Okay, listen carefully. So you're told h of x is 47. Now be careful. You don't substitute 47 in for x, because that's not what this says. This does not say h of 47. So be careful. Be careful. H of x equals 47 does not mean h of 47. Okay, that's not what that means. H of x equals 47 means this. Means what is x when y equals 47? That's what that means. So what is x when y equals 47? Remember, h of x means the same thing as y. So y is 47. All you do is this. To find this right here, all you do is go back here. See, this is h of x. You want this to equal 47. So here's what you do. 6x plus 5 equals 47. Because 6x plus 5 equals h of x, right? And you're told h of x is 47. So set equal to 47, and then get x by itself. So subtract 5 from both sides. I get 6x equals 42. Divide both sides by 6. I get x to be 7. So the answer is 7 right here. And it kind of makes sense because watch, when x is 7, watch at this. When x is 7, what's 6 times 7? 42. 42 plus 5? 47. All right, now, so find h of 7. Well, h is 7. When x is 7, what's my y value? It's 47. Now they're asking this. Well, what if h of 7 equals 47? If h of 7 equals 47, then what is h inverse of 47? What do you think that equals? You should be able to know this now. So based on all the stuff we talked about, h inverse of 47 equals 7. It's equal to 7. Now, here's another way you can think about it. So you know this right here means this. 747 is on the graph of h of x. So if 747, when x is 7, y is 47, that's what this says, then on the inverse, 47, 7 is on h inverse of x. So if I want to find h inverse of 47, say x is 47, when x is 47, what's my y value? Well, my y value is 7. All right, so that, and then by the way, this, if you look at this, this is the worksheet number 2. So I gave you, I just did some examples very similar to that worksheet. Okay. All right. So that is worksheet number 2.